orders, and it would, it would give monodenic orders that have index at most, maybe something like square free index in the maximum order, something like that. So instead of saying index 1, it would be allowing square free index. Thank you.
Thanks for the introduction, and thanks to the organizers for inviting me to speak. It's a great pleasure to be here and talk about this work, which has been partly done at MSI during this spring. So I will talk about the correlations of von Magnus and higher order divisor functions, and everything is joint work with Maxime Brazzaville and Terence Tao. And let me start just to make sure that everybody knows what we are talking about. I will define the von Magnus and divisor functions. So we write lambda n to be log p if n is a power p and 0 otherwise. And we write dkn to be the k-fold divisor function. So it's the number of ways we can write n as a sum of k things. So it's a generalization of dn, which is just the k equals 2k. And then I will talk about correlations of these, but let me start with the twin primes. Okay, so if we want to study twin primes, then this is the same thing as looking at the sum of n up to xa, indicate the function of n is a prime, times indicate the function that n plus 2 is a prime. Okay, so if we can show that this is, say, or something, if this is tending to infinity with x, then we can show that there are infinitely many twin primes, and studying the indicator function of the primes is essentially the same as studying the von Magnus function. So we can, understanding twin primes also corresponds to understanding this lambda n plus 2. And this is the thing that I call correlation. So we have a function, say lambda n, and I look at it at 2 points, and I want to know if it's correlated with values at lambda n and lambda n plus 2, if they are related or not, if there is some correlation going on between some consecutive values of the function or some k-step values of the function. So for the von Magnus function, there is certainly correlation. The lambda n and lambda n plus 1 certainly know about each other. One of them is always 0, but then the question is how much lambda n plus 2 is there. What's happening if you look at the sum of these things. And if we can show a reasonable lower bound for this, in particular tending to infinity, then we can show that there is infinitely many twin primes. So it's interesting to study correlations of the von Magnus functions. And in general, I want to talk about, instead of having 2 here, having h here, which is similar. And then because we can't do twin primes, I want to average over different ages. But let's first state what we expect to be true for such a correlation. So it's a good conjecture. Says that if we look at this from the n plus 8, then this should be asymptotic to sigma series depending on h times x plus big O x plus 2 of 1, and this of course would imply that there are infinitely many twin primes and the asymptotic formula for them, and here let me define this sigma series. So here this g of h is 0 if h is odd, because then there are not many pairs of things that are both primes. The difference h, there is at most you have 2 or powers of 2, one of them must be a power of 2 if h is odd, and in cases h is even, this is 2 times the product of primes, 1 minus 1 over p minus 1 squared. So this is the so-called twin prime constant, but there is something depending on h as well, which is p divides h, p greater than 2, and p minus 1, p minus 2. So this essentially corresponds to the probability that both of these are primes, because there are some obstructions or some things which affect this modulo small prime. So for instance, if h is 3, then in order for both of these to be prime, n must be 1 or 2 mod 3, not 3 mod 3. So there are some things that become into this sigma series. But anyway, we have very good conjecture about this, what happens. We have a clear main term and then there is a small error term, but the thing is that we of course can't solve it, but this is true.